This video we'll look at how to find the area of a segment. So we'll start off by first identifying what we mean by segment. So in this diagram we have a circle, we've got a triangle drawn within that circle. When we talk about the segment, we're talking about this section right here. So if I just shade in this part, so it's a part of a circle but not the whole thing. So how do we find the area of that segment? And at first that can look kind of daunting, but what we can do is we can kind of break this up into a couple of pieces. Maybe before I do that, I'll just label this as a segment so we know what we're referring to. And in order to find the area of the segment, what we can do here is we can find the area of the sector. So just a reminder that when we talk about area of a sector, we're talking about, let me just see if I can highlight. We're talking about this. We'll use a different color for that maybe. When we talk about the area of a sector, we're talking about the area of a portion of the circle, basically that runs from the center of the circle out to the edge. So that is a sector. So maybe I'll mark that up in green so we can see that. And once we have the area of the sector, all we have to do is subtract the area of the triangle that you can kind of see in here. Do that with a highlighter so you can see it a little bit better in a different color. So if we can take the area of the sector and subtract the area of the triangle, that will give us the area of the segment. So that's kind of what we're after here. So just call that a triangle so we can refer to it. So let's write that down. The area of the segment, do that over here. So the area of a segment, so I'll just put segment as a subscript so we know that that's what we're talking about, is equal to the area of the sector minus the area of the triangle. In this case, that's triangle ABC. So that's kind of our goal. If we can find the area of the sector, find the area of the triangle, we'll subtract them, and we'll come back to this idea here. So let's start off by first finding out the area of the sector. So the area of the sector is whatever fraction of the circle this is. Maybe I guess we need to start with a couple of given values. So let's maybe just off to the side here because our diagram's getting a little bit busy. We'll say that angle ABC is equal to 70 degrees. And we also need a radius for this circle. And in this case, the radius will be, let's use 4.2 as our radius. So here's a radius from the center of the circle out to the circumference. So those are two radii. So the area of the sector is just equal to whatever fraction of the circle this is. So we can find the area of the circle and find out which fraction of the circle it is. So maybe I'll write that as well. Fraction of the circle. Circle times the area of the circle. So if we were doing half the circle, we would do 1/2 times the area. This obviously isn't half. We do know that this is 70 degrees in here. There are 360 degrees in this whole circle, so the fraction here is 70 out of 360 degrees. So we know the fraction of the circle is 70 out of 360. And then we're going to multiply that by the area. Just a reminder that the area of a circle is just pi times the radius squared. So it's pi times the radius, in this case we said was 4.2. We'll call it centimeters. Could be any units, but we'll just stick with centimeters for now. And again, we can simplify this. We can divide divide by 10. Not divide by 0, but divide by 10 in both the numerator and the denominator. And then we get 7 out of 36 times pi times, oh, I forgot my squared here, pi r squared. And then we can plug that into a calculator. And when we do that, we get that the area of the sector is approximately 10.8 centimeters squared. So 7 divided by 36 times pi times 4.2 squared should give us approximately 10.8, and that is the area of the sector. That's the part here in green. So we know that the area of the part in green is 10.8. We'll find the area of the part in red now and go from there. All right, in order to do that, a couple things need to happen. So we can see that we have a triangle here. We actually know the lengths of that sides of the triangle. This is 4.3. This is 4.3. But remember that if we're going to find the area of a triangle, so maybe we can do that over here. Area of the triangle is equal to 1/2 the base times the height. So we need to know the base of the triangle. That's this side AC, and we also need the height, and that height is the perpendicular height. So we need to find that value. There's a couple ways that we can do this. I think we'll try to do this the easiest way, but if you find another way, that's okay too. So in order to do this, what we're going to do is, I'm just going to see if I can duplicate this just because that circle is getting a little bit crowded, and we'll just work with it over here. All right, so we have this circle ABC. What we're going to do is we're going to draw a radius through that circle, or at least part of a radius that comes like this. So if we were to extend it, well, maybe we'll go all the way. The radius would look like that. And if we're drawing the radius through the circle, to this edge of the circle through this chord, then what happens is we get a bisection of the chord. So these two lengths here are the same length. We also get a 90-degree angle based on the circle properties that we've looked at. So this angle here is 90 degrees. There we go. The other triangle is exactly the same. We do know the radius of this triangle. Oops, I think I wrote 4.3 up here. That should be 4.2. So we get 4.2 here. Let's work at finding the height. We have a triangle. We want to find the height. Ultimately, we want to find the base as well. Let's start with the height. Now we know that this angle here is 70 degrees. And if that angle is 70 degrees, because this is an isosceles triangle, this big triangle ABC is an isosceles triangle, both of these being radii, we know that these two angles in here, angle A and angle C, have to be the same. So angle A equals angle C. That's because that's an isosceles triangle. And we also know that the angles in a triangle have to add up to 180. So we know that 180 minus the 70 degree angle at B, that's this one over here, whatever that is, divided by 2 has to equal angle A and angle C. This gives us everything that's left, and we know that the angles are the same, so we divide it by 2. So 180 minus 70 is 110. 110 divided by 2 is equal to 55. Whoops. Angle A equals 55 degrees. So now we know this angle up here. We have a side length, we have an angle, we can then use that information to find h. It looks like in my diagram that h goes all the way to the edge of the circle. That would be a radius. We're not really interested in that, so I'm just going to shorten that line segment a little bit. Maybe. Let's see if I can grab it. There we go. Just shorten it up. Well, I might just erase it and try again. Because what we're really interested in is just the triangle portion. There we go. All right, so we have this right angle triangle. We want to find h. So let's find the height of the triangle. Let's try that again. All right, so here's our triangle. This is obviously the hypotenuse. And this side here, this is the angle that we have, so this will be the opposite side. So now we know that the ratio that uses opposite and hypotenuse is sine. So the sine of 55 degrees is going to equal the opposite side, which is h, divided by the hypotenuse, which is 4.2. We want to solve for h, so let's multiply both sides by 4.2. And then we go to our calculators. Again, make sure your calculator's in degrees when you do this. Otherwise, you'll get the wrong answer. So if we do 4.2 times the sine of 55, we should get approximately 3.4. So this height in the triangle right here is 3.4 centimeters. All right, so we have the height. Remember, our goal is to find the area. We now have the height. We need the base. A couple ways that we can do that. We can do that with trigonometry again on this triangle here, or we can use the Pythagorean theorem. So what we have left is we know that this is 3.4 centimeters tall. We know that this is 4.2, and we want to find this. I'm going to call it x. I was going to call it b for base, but it's the base of this little triangle. It's not the base of the whole thing, so let's keep that in mind. So if we want to find x, we can use the Pythagorean theorem. So we know that 4.2 squared is equal to 3.4 squared plus x squared. And if we work this all out, we get 17.64 is equal to 11.56 plus x squared. And now we just want to solve the equation for x. We're going to subtract 11.56 from both sides. I'll just write that down here. Whoops, lost my decimal point. All right, and when we do that, we are left with 6.08 is equal to x squared. So x is equal to the square root of that, and we get approximately 2.5. It's not exactly 2.5, but it's approximately. Now remember, x was this value right here from the edge of the circle to the center of that chord. So we know that's 2.5. We could repeat the process on the other side, or just say, hey, this one also has to be 2.5. That means that the base of the triangle is 2 times 2.5, which is equal to 5 centimeters. And again, don't forget the reason why we want that base is we want to be able to find the area of the triangle. The area of the triangle is half the base times the height. Hopefully I don't run out of room here. So let's find the area of the triangle. The area of the triangle is 1/2 the base times the height. Remember that the base is 5. And the height we found earlier, way over here, was 3.4. 1/2 times 5 times 3.4. That will give us approximately 8.5 centimeters squared. I just rounded to the nearest tenth. So that's the area of the triangle, right? We said earlier that if we can find the area of the sector and subtract the area of the triangle, we'll get the area of the segment. Well, we have the area of the sector, we have the area of the triangle, so the area of the segment is equal to that 10.8 that we found for the sector minus the 8.5 centimeters squared for the triangle, and that will give us a total area of 2.3 centimeters squared. And again, that's for the area of the segment. So one of the nice things about this is it pulls together a whole bunch of ideas, right? There are some circle properties involved here. There was some trigonometry. There was a little bit of Pythagorean theorem. Hopefully those concepts are familiar to you and are comfortable, because if you have a good grasp on those things, then the little bits and pieces here aren't so bad. So again, that was how to find the area of a segment.